In this lesson, we're going to be looking at some exact trigonometric values. So we're going to be looking at exact values of sine and cosine and things like that. Because we are looking at the exact values here, that means that I'm not going to want decimal approximations, which means that we're going to be doing this particular lesson entirely without a calculator. And that's going to be really the entire point and purpose of this, is seeing how we can know some of these things without having to rely on our calculator. So the first question we're going to take a look at here is, what is the cosine of 30 degrees and the sine of 30 degrees as exact values? Now, of course, you could put these into your calculator, but if you did, you would end up with some decimal approximations along the way, and that's what we're trying to avoid, which is why we're going to be looking at this that different way. And so in order to do this one, I'm going to start by building the right triangle into the unit circle there. So I drop it down to the horizontal. And then we need to know our sine and cosine values. Well, remember that the hypotenuse, because this is going to be a unit circle, because whenever I'm drawing a circle on these, I'm going to go ahead and make them unit circles. So that means my hypotenuse is 1. And in that sort of case, we know that the adjacent side then becomes the cosine of our angle. So this is going to be cosine of 30 degrees here along the horizontal. And this is going to be sine of 30 degrees on our vertical. And remember that those also correlate to the x and y coordinate pair that goes with this point. This is how we're going to be correlating this also to some unit circle information here, where we know that the x coordinate is cosine and the y coordinate is sine. So this is also going to tell us coordinates on the unit circle as we learn some of these exact values. Now notice what we have here. We have one of our special right triangles. We have a 30, 60, 90 right triangle, which means that if I go back to the picture of the 30, 60, 90 right triangle, I can actually figure out now what these two values are. Because notice I have my 30-degree angle right here. That, of course, correlates with this 30-degree angle up here. So if I want to see what the adjacent side is, notice the adjacent side here is going to be root 3 over 2. That's our adjacent, which means that that is going to be the cosine of 30 degrees. And the opposite side, notice the opposite side of each, that means the 1/2 must go with the sine of 30. So then sine of 30 equals 1/2, and cosine of 30 equals the square root of 3 over 2. And those are then considered the exact value. And again, I knew those values because I could see that I was dealing with one of those special right triangles, specifically the 30, 60, 90 right triangle, and was then able to just go to that picture and see what those values actually are there. We're going to repeat that process with this picture. In this case, we're again going to try to find the cosine and sine values, in this case of 45 degrees. And notice it's 45. Again, that's one of those angles that's involved in those special right triangles. And so I'm going to want to take a look at the 45, 45, 90 right triangle. And so knowing that, notice then that I can know that from a 45-degree angle, that the adjacent side is going to be root 2 over 2. So that means that this is root 2 over 2 down here. And that the opposite side is root 2 over 2. Okay, so what does that tell us? Remember that the adjacent side to my angle that's involved here is going to be cosine, and that the opposite side is going to be sine. That is, the horizontal is cosine and the vertical is sine. Both of those ways of looking at it are both valid and both useful in different scenarios. So yes, get used to being able to look at it either way, and that's going to help you to be able to digest these. All right, so then in terms of the original question, what is cosine of 45 degrees? We would say that is root 2 over 2. And what is the sine of 45 degrees? That's going to be also root 2 over 2. All right, having done those two, this one's going to work very similarly. Take a look at this, figure out, okay, what do you think those cosine and sine values would be using what we've done, and then we'll check it together here in a moment. So notice in this case, again, it's one of those special angles. In this case, it's a 60-degree angle. And because it's a 60-degree angle, that tells me to go to the 30, 60, 90 right triangle. Now, I already used this one earlier, but this one's going to give us a few different values, or at least different values in different places, because the last time we were going from the 30-degree angle. In this case, though, we're going from the 60-degree angle. The nice part about this particular one, though, is that means it's already turned the exact same way as my picture up here is, where the 60-degree angle is in the bottom left-hand corner of this. That's going to make matching up the pieces that much easier. And so notice, yes, our hypotenuse is 1 in both cases. That's because it's going to be defined as the unit circle, which means that this side down here is 1/2. Now, that side, is it sine or is it cosine? Hopefully you're saying cosine there, because cosine is always going to be that horizontal. It's the x value. So my exact value of cosine of 60 degrees then is 1/2. And then what about the opposite? Well, notice the opposite side over here is √3/2, so this opposite is √3/2, which is going to be our sine value. And so then the sine of 60 degrees is the square root of 3/2. We can then summarize those values that we just found in this little table. So these are each of the 3 different sets of values that we just found for sine and cosine. Now, normally I would say this is a great time to put this into your notes, but strictly speaking, you don't have to have this in your notes because we're going to be actually expanding this out and putting a much bigger picture into your notes here in a minute. But you do want to at least have these values handy, so if you didn't write them down with the work that we were doing earlier, you might want to write them down now because it's going to help us to piece some other things together going forward. Next up, I want to figure out what the cosine of 120 degrees is and what the sine of 120 degrees is. So as we take a look at this picture, again, cosine is going to be the horizontal and sine is going to be the vertical. And so again, I could also correlate it as cosine is the adjacent, sine is the opposite, except that if the angle is here, adjacent doesn't make quite as much sense. And opposite, what would that be, like somewhere over here? And so when you take a look at this particular picture, we can actually change it up just a little bit. And this is a way that we can know some of these values without having to get into a whole new, brand new way of looking at these. We can take what we've already seen and apply it here. So let's do that. Instead of just looking at this 120-degree angle, if that angle is 120 degrees, what is this angle going to be down in here? Well, the whole line, remember, is 180. And so what's left out of 180 if I take out the 120? Yeah, it's a 60-degree angle. And so then notice, because that's now 60 degrees, that means I'm dealing with another one of those 30, 60, 90 right triangles. And again, I can see the 60 degrees and the 60 degrees, and I can match those up to figure out what the side lengths are. So if I want to know what the cosine is, that means I want to know what the adjacent is. The adjacent, as we can see down here, is 1/2. So the cosine of 120 degrees is 1/2. And the opposite, well, notice in order to be able to get the opposite, which is sine, I'm going to be doing the √3/2. So sine of 120 degrees is √3/2. Okay, we've done some good work here. There's just one little problem. One of those answers is not entirely right yet. We need to tweak one other thing about it because we just filled in those values based off of our 30, 60, 90 right triangle down here. Well, remember that the actual cosine and sine values also correlate to the coordinates of the point up here on the unit circle. So we know that it's going to correlate to the x and y up here. Well, if that's going to be the x and y coordinate pair, notice that it's in the second quadrant. That means in order to get there, I had to actually go left, which means if my origin is here at 0, 0, right here in the middle of my circle, that means that my x-coordinate must actually be negative, which means that the cosine of 120 is actually a negative 1/2. And so that's the one little wrinkle that we throw into this as we start taking a look at these other values as we continue going around the circle, because we really can just keep going around the circle looking for more and more of these values. Just we aren't going to be looking at every single possible angle there exactly. You'll notice I'm only picking a few of those. I'm not checking, for instance, what the cosine of 50 degrees is, or the sine of 13 degrees. What we know in order to be able to find these exact values is the special right triangles. And we only have two of those special right triangles in our pocket right now. We have the 30, 60, 90 right triangle, and we have the 45, 45, 90 right triangle. So those are the only ones that we're going to be focused on as we go forward. This is a picture showing all of those angles labeled that we can know just based off of the information we already know, particularly about the 30, 60, 90 triangles and how sine and cosine behave. And as we take a look at this, we of course can find those angles where we start off at 0 here at horizontal right, and then we always are going counterclockwise from there. And so notice that I'm just putting in the increments that are going by 30s and by 45s basically. So here we have the increments that go by 30 degrees, and then kind of squeezed in between them, we have those increments that are going up by 45. And there's overlaps, notice, along the horizontals and verticals. Okay, and so by knowing those, just the 30, 60, 90 triangle in red, and the 45, 45, 90 triangle marked on the blue there, you can see that we're going to be able to figure out some stuff with those. Now, we already did figure out some of those values. We already figured out these earlier in this lesson. We figured out these sine and cosine values. And we can continue going around and finding more and more of these values. So for instance, if I wanted to figure out 135, the sine and cosine, well, one of the cool things about this is that because that forms a 45, 45, 90 right triangle, just like this formed a 45, 45, 90 right triangle, we actually already have the values there. You notice that it's got to be the same. So we still have to have like the root 2 over 2 and the root 2 over 2. The only question is there another negative that's going to be thrown in here? Well, notice we are headed over here to the left as we find that value. And so I would expect my x-coordinate to be negative. Now again, which of those is the x-coordinate? Is that the sine or the cosine? You should be checking yourself as we go through here. It is the cosine that is the x-coordinate, and therefore the cosine is negative here, which you also have another hint of because you'll notice both of those cosines are negative. Within any given quadrant, all the sines should have the same sign, and all of the cosines should have the same sign, that is positive and negative. And so I can also then do the same thing here, for instance, at 150 degrees. You notice that the coordinates of that triangle really should be the same as the coordinates of this triangle. The only difference is that something's going to need to be negative. So I'm going to start by saying that I know that the sine is going to be 1/2 and cosine is going to be root 3 over 2. And I'm just copying those values from over here. Using what I know about a special right triangle would also work. Just I then need to figure out which one of them is negative. Remember that all of our x-coordinates were negative, making all of my cosines negative here. And so I'm going to have a negative root 3 over 2 there. And we can continue doing the same thing, even going down as well. So for instance, if I wanted to figure out 210, notice I'm dealing with that triangle. That looks a lot like this triangle up here, doesn't it? And so again, I would expect those values to basically be the same thing. We're just going to have to check the signs. So like sine is going to be 1/2, cosine is going to be root 3 over 2, and then we ask for each of those. Would I expect the sine to be negative or positive, and would I expect the cosine to be negative or positive? So the sine, remember the sine is my y coordinate. It's how far I'm going up or down. In this case, because I'm going down, sine would be negative. Cosine is my x coordinates, how far I'm going over. Since I'm going to the left from 0, it too will be negative. And because of that, I know that all of the sines and cosines here in the third quadrant will be negative. And so I can just start filling that information in. And we can follow that exact same information all the way around the circle. to get all of those different values for sine and cosine. Although we did skip a couple of values that I want to take a look at now. We're going to look at those horizontals and verticals. And for these, we actually don't even need to know special right triangles. What we do need to know is unit circle. What again is the radius of my unit circle? Hopefully you're remembering 1. That's why it's called a unit circle, because the radius is 1 unit long. And so knowing that, I want to know what are the coordinates of this point right over here at 0. Well, the sine is how far I'm going up or down. I didn't go up or down at all there, and so it's 0. The cosine is how far I'm going over. Notice I'm going all the way over from the center to the outside of the circle. That must mean that it equals the radius, which, given that it's the unit circle, is 1. And so we can know the sine and cosine at 0 just by knowing that it's a unit circle and that we're going straight over and things like that. Now, knowing that, we should then be able to go up and figure out what 90 degrees would be. So if I go up 90, notice I'm going up but not over, which means that my sine would have to then be 1 and my cosine would be 0. Because remember, sine is my y coordinate and cosine is my x coordinate. All right, next up, we're going to go to 180. Notice I'm going over and not up at all. And so then my sine would be 0 because I'm not going up at all. And my cosine, well, it's a lot like 1, but it isn't exactly 1 because notice I am going to the left. And if I'm going to the left, that means it's negative 1. Finally, if we go straight down at 270 degrees here, notice I am going down 1, and sine is my y coordinate, so that means I'm going to have a sine of negative 1. And I'm not going over at all, which means that my cosine then would be 0. Now, sometimes people get thrown off because all of a sudden I was talking about sine and then cosine, but when we talk about coordinates of points, x and then y, in that case, it's cosine comma sine. So what's the difference here? It's just a way of talking about these. When we talk about the coordinates, yes, cosine comes first. But when we talk about sine and cosine values, we tend to talk about them that way. We talk about sine and cosine values in that order. So don't get hung up on just memorizing a particular order. You actually have to know what each of these values actually mean. And with that, we now have a complete picture about what's happening in terms of the exact sine and cosine values at many, many different angles. And in fact, we could even extend our knowledge about this picture even one step further, because all of these angles that I have labeled here are in degrees. But as we've seen, that's not the only way that you can measure an angle. We also recently talked about how angles can be measured in radians. And so I could actually go through and figure out what each of these different angles are in radians. And if I went ahead and did that and filled in all of those angles, this is what I would then have. So this picture now includes the degrees of all of our significant angles, the radians of all of those significant angles, then also the sine and cosine values at each of those angles. I suggest you have a copy of this written down and in front of you, because if you have this, it makes finding some of these answers that we're going to be looking at very, very easy. Mostly in this lesson, we've just been building up to how we can know what these values are. And we're just laying a foundation for how we can get to these values. From here, we're going to look and see how we can use these values to answer some questions, which otherwise would be pretty tricky and maybe even impossible. But now that we've seen this process, are actually going to be very easy. So to see how we can take what we just did and turn it into something very fast and useful for us, we're going to be figuring out this problem. What are the exact values of cosine of 240 degrees and sine of 240 degrees? Now, if we did not have that picture in our notes, we would have to draw out a circle, and within that circle, we'd have to be able to identify where is 240 degrees, and then we'd have to build a triangle around that, and then we'd have to figure out, okay, what does that make our central angle? and then figure out the corresponding sine and cosine values that go with that based on our special right triangles memory. But of course, I said that was only if we did not have it written down. If we do have that written down right in front of us, we can figure it out just by looking at it basically. Now, I know that you should have these values written into your notes, but just to kind of bring it home about why we end up getting that as our value. So notice if I build this triangle here, that's like a 60-degree angle. And this is also going to help you to start memorizing it a little bit, because eventually you will actually have to have these values memorized. Not necessarily this year, although normally during a regular year you would have them memorized by the time we were done. So that's a good goal to have. But you'll definitely need to have them memorized during next year's math class. So I can see that that is a 60-degree angle. So this is what I'm thinking in order to come up with this off the top of my head too. And so that being a 60-degree angle, I then know that the opposite length is root 3 over 2, and that the adjacent length is 1/2. Based off of that, I then could know that the cosine would be 1/2, because that's how far I go over. The sine value would be root 3 over 2, because that's how far we go up or down. And then I look at the sines. I want to know if it's positive or negative. And so since I'm going down, sine will be negative. And since I'm going to the left, cosine would be negative. And that's how I could actually come up with those values should I not have the notes in front of me. But of course you do have these notes in front of you, and so you could actually just look it up like that. All right, on to the next one. The exact value of sine and cosine of 135 degrees. So for each of these, again, I want to talk about how we could kind of know it off the top of our head as well. You know, how can you start getting to remember these a little bit more? Well, if I take a look at my unit circle picture, of course, I've again omitted that one set of values that we're trying to find here. Notice that this triangle is a 45, 45, 90 right triangle. And so knowing that it's 45 and 45, I'm going to end up with those same values that I do over there at 45. So it's going to be the root 2 over 2 and the root 2 over 2. You'll find that's actually one of the first ones you'll really memorize because they're both the same. It makes it easier to get there. Just we have to now pay attention to the positives and negatives between them. So in this case, one of those will be positive and one of those will be negative. Can you tell me which one? I hope so. Hopefully you're coming up with the cosine is being negative here. There's a couple reasons I can know that. One is cosine is the horizontal here. And so if cosine is that horizontal, notice I'm heading to the left, which means I'm heading in the negative direction. Therefore, cosine, the x-coordinate, must be negative. The other way is that the other cosine values in that quadrant are negative. Therefore, that cosine value in that quadrant must also be negative. They're negative all for the same reason. All right, last one we're going to be doing here together. What are the exact values of cosine of pi and sine of pi? Now, you'll notice that pi is involved, which is already a pretty big hint that we're going to be dealing with the angle measured in radians, not in degrees. The other way that you can know that is that there's no degree symbol written in here. We have to write that degree symbol if it is indeed measured in degrees. Without it, it is assumed to be in radians. All right, so we want to know those exact values. So I again want to bring up that picture and take a look at what's going on here. And as I'm visualizing these in my head, because of course I had to memorize these many years ago, and I always have to call back this information as we're doing problems, and yes, you will too, because as you go higher and higher in math, unit circle values come up more and more. So in order to be able to do this, I picture in my head where the angle pi is, and I can see that the angle pi is over here. It's at 180. Lots of practice helps tell you where pi is. Although it's one of the early ones you'll memorize, because if 2 pi is the entire circle, pi must be half the circle. But anyway, looking at that point, I visualize where that point is on the circle, and I can see I'm going straight to the left. I am not going up or down at all, which means that my sine value must be 0. But I am going over the full radius of 1. But since I'm going to the left 1, that means my cosine is -1. And that's the sort of thought process that you start using as you start learning these values. And again, as you use this unit circle picture, yes, I'm expecting that you're going to be able to just look at it and be able to use this as part of your notes in order to be able to answer many of the questions you see in this week's assignment that are based on it. However, I do want you working on memorizing it and working toward knowing more and more of these values just by heart, because it's going to help you very, very much in upcoming math classes.